Hi guys, and welcome back to our first lesson in our fractions topic. Today we are going to be looking at equivalent fractions. So we're learning what a fraction is and how to identify an equivalent fraction. You will have been successful today if you can identify the numerator and denominator of a fraction, and if you can scale or simplify fractions to the correct equivalent fraction. So a fraction is a number that represents part of a whole. So if we take this white rectangle as one whole, we can see that it has been split into 8 parts. So if we were to shade in this one section here, we would say that that is worth 1 out of 8. If I were to shade in these 3 here, I would say that that is 3/8, 3 out of 8. So our fraction is made up of 2 parts. We can see here 3 on the top and 8 on the bottom. So we would call the 3 our numerator. And that tells us how many of these fractions that we are looking at. So here we've got 3 of 8, and 8 is our denominator. The denominator tells us how many parts our whole shape has been split into, and the numerator tells us how many of these parts we have. Here I've got a fraction grid, so you can see that my top row, the whole rectangle has been split into halves, and we have 2 of them. On the next row we've got thirds, then quarters, then a sixth. So what I'm going to do to start off here is I'm going to shade in this top row along here. So I've shaded in 1/2. If I skip my thirds and go to my quarters, I could shade in this first quarter and the one beside it, so 2 quarters. And that means I've shaded in the same amount as my first row, so 2 quarters is equal to 1/2. If we go to the row below, you can see that if I shade in 3 of my sixths, I've also got 1/2. So I'm hoping here that you can spot how many I need to shade in of each of the other rows. So if we look at 8s, I would need 4/8 to match up. My 9ths I can't do equally, but my 10ths I'll need 5 of them. 1, 2, 3, 4, 5. And then on my last row for the 12ths, you can see that I'll need 6 of them. So 1, 2, 3, 4, 5, 6. And shaded in there, I've shaded in 1/2 for each of those rows that it'll work for. It's not just 1/2 that has these equivalent fractions. Let's use the red so it'll stand out. If I shade in 1/3, we can see that 1/3 is also going to be equal to 2 of my sixths, or 3 of my ninths, or 4 of 12ths. And again, really quickly, this time if we do green, if I shaded in that 1 quarter here, 1 quarter can also be made up of 2/8. We could also shade in, what would that be, 3/12. Like so. So these are what we call equivalent fractions. So fractions that have different numbers from each other, but they are worth the same amount. So 1/2 is equivalent to 2 quarters, 3/6, 4/8, etc. It's possible to find a fraction equivalent to any other fraction that you have by multiplying the numerator and the denominator by any number. So if I take my 2/3 and times the top by 2 and times the bottom by 2, 2 times by 2 is 4 and 3 times by 2 is 6. So there, 2/3 is equivalent to 4/6. I've said here if we multiply by any number, so let's pick our 5 times table. 3 times by 5 then, and 7 times by 5. Well, 3 5s are 15. And 7 5s are 35. So 3/7 are equivalent to 15/35. it's important that we remember whatever we do to one number, we have to do to the bottom. So we times the top on our first one by 2, so we times the bottom by 2. And then the second one we picked 5, so we did the top times by 5 and the bottom times by 5. I can't do the top with one number and the bottom with something else. It's no longer equivalent in that case. So what I would like you to do is watch me do the first example, and then I want you to pause the video and try it with the next 3. So we're going to write down 4 equivalent fractions to 1/3. So if I times the top and the bottom by 2, I would have 2 over 6. Then if I times my original one by 3, 1 times by 3 is 3, 3 times by 3 is 9. Then 4, so 1 times by 4 is 4, 3 times by 4 is 12, and then if we times by 5, 1 times by 5 is 5, and 3 times by 5 is 15. So just using the 2, 3, 4 and 5 times table, pause the video and try the other 3 for me. Okay, let's see how we get on then. So 2 times by 2 is 4, and 5 times by 2 is 10. 2 times by 3 is 6, and 5 times by 3 is 15. 2 times by 4 is 8, and 5 times by 4 is 20. And then 5, 10, and 25. For 3/4 then, we should have 6 over 8, 9 over 12, 12 over 16, and 15 over 20. And then last but not least, we would have 10 over 16. We would have 15 over 24. We would have 20 over 32. And then 25 over 40. And that's us written down 4 equivalent fractions to each of our starting fractions there. Like I said before, whatever we do to the top, we must do to the bottom. So we are going to fill in these missing blanks to make our fractions equivalent. So to get from 1 to 7, we've had to multiply by 7 here. So I need to times by 7 in the bottom. 3 times by 7 then is 21. So 7 over 21 is equivalent to 1/3. For 2 to 12, I would need to multiply by 6. So I need to multiply by 6 in the bottom, and 5 6s are 30. My menu's a bit in the way at the bottom there, but 3/4 is equal to something over 12. Well, I would have had to times by 3 to get from 4 to 12. So times by 3 on the top, so that should be 9/12. And for the last one, 8 to 40, well, I need to multiply by 5. So multiply 5 by 5 to give me 25/40. We can also reverse our equivalent fractions to write them in their most simple form. So sometimes you can be asked to simplify or write them in their simplest form. So I'm looking for what times tables my 2 numbers are in here. So 3 and 6 are both in my 3 times table. So I'm going to divide my top and bottom by 3. Whatever I do to the top, I must do to the bottom. So 3 divided by 3 is 1, and 6 divided by 3 is 2. So 3 6 can be simplified to 1/2. 4 and 8, well, they're both in the 2 times table, but they're also in the 4 times table. So we always want to look for the biggest table that they are both in. So 4 divided by 4 and 8 divided by 4. Well, that should give me 1 over 2 to be 1/2 as well. So 3 6 is equivalent to 1/2, and 4 8s are also equivalent to 1/2. So to simplify a fraction, as I said, we always look for the biggest times table that both of our numbers are in, and we divide the top and bottom by that same number. So 6 and 18, they're both even, so they're both in my 2. They are both in my 3 times table, but they're also both in my 6. So I'm going to go straight to my 6 times table here and divide by 6. So 6 divided by 6 is 1, and 18 divided by 6 is 3. And then we've got 1/3. So I've done a couple of examples there for you. I would like you to pause the screen here and try these 4 examples, and then come back and I will try and help answer them for you. Okay, hopefully we gave that a good shot there. 5 and 10 are both in my 5 times table. So I'm going to divide the top and the bottom by 5. And that is going to give me 1/2. 4 and 16, they're both in my 2, but they're also both in the 4 times table. So we can divide by 4 and divide by 4 again. So 4 goes into 4 once, 4 goes into 16, 4 times. 6 and 24 are both in my 6 times table. So I'm going to divide the top and the bottom by 6 there to give me 1/4. Is that going to be 4? And then 40/50, well, they both end in a 0, so they're both in my 10 times table. So 40 divided by 10 is 4, and 50 divided by 10 is 5, to give me 4/5. So it won't always be 1/, something. Sometimes the smallest fraction we can simplify to will be any number over another. So 4/5 is acceptable as an answer. For some of those examples there, you maybe didn't quite get to the same answer as me, and that's because we don't always spot the biggest times table straight away. For 80 and 100 here, I'm thinking they both end in a 0, so I'm going to divide by 10. So I think that's my easiest times table to work with just now, and that's going to give me 8/10. But 8 and 10 still have a times table that they share, and that's our 2 times table. So I'm going to go in and divide by 2 and divide by 2, and that's going to give me 4/5. Now 4/5, 4 and 5 are not in the same times table, so I know that I've fully simplified here. So it's always important to check once you get an answer, like we did our 8/10, can we make it any smaller? In this case, yes we could, to 4/5. So really important, always check, have you fully simplified your fraction? Well done for sticking with that lesson to date. A wee bit longer than our last couple of lessons, but I wanted you to have plenty of examples to help with these questions. As you can see here, I've used our chili rating like I've done in the last couple of lessons that we've had. So here, 1, 2 and 3 are our mild questions. I really expect most of us to be able to do these ones. So these are our scaling up. You should be getting bigger fractions each time. Our medium questions here are a mix. So the top one is you multiplying to get bigger numbers each time. For 5 and 6, you are doing our simplifying, so you should be getting smaller each time. And lastly, question 7, our hot questions. You need to simplify each of those, but this time it doesn't tell you what to simplify by. So 5 tells you to simplify by 2, 6 tells you to simplify by 3, but for question 7, you need to spot which times tables both those numbers are in. Try your best for me and let me know if there are any problems. I'm always there checking teams to see how we're getting on with our questions. Give it your best shot, and I'll see you in the next lesson.